PCC KMnO4 Jones reagent. Students often mix them up and lose easy marks. In this video, I will give you a simple framework to remember every important oxidation reagent and crack exam questions faster. Hello students, let us start. Reagents for oxidation, part 2. Oxidation of alcohols. Copper at 300 degrees Celsius acts as weak oxidizing agent. Like primary alcohol gives aldehyde, secondary alcohol gives ketone, whereas tertiary alcohol gives alkene after elimination of water molecule. So you can specify here it as secondary alcohol as well as tertiary alcohol. Oxidation by periodic acid. Here you can observe HiO4 can oxidize only these groups, diols, OH and CO side by side, 2 ketone groups, or ethylene oxide with methyl group substituted. Only syn diol here and COH, NH. Only these groups oxidized by HiO4. Trick is break the bond, add OH to each side. Break the bond, add OH to each side. If same carbon having 2 OH groups, eliminate one water molecule. See here. Break it, add OH here, OH here. So same carbon having 2 OH groups, eliminate water molecule. Left over you will get 2 aldehydes. Here also same. Break this bond. Break this bond. Here OH, here OH, here OH. So here 2 times OH groups added to CH. Middle carbon 2 times oxidized. That is converted into carboxylic acid instead of aldehyde. Here aldehyde, aldehyde, 2 aldehydes. But middle carbon 2 times oxidized because this side OH we are getting, this side also OH. So overall 2 OH groups we are adding to this. Hence carboxylic acid framed. 1,3 diols, no further reaction with HiO4. Cis diol reacts to form here, break the bond, CHO, CHO. Trans here rotation is locked, at the same time here trans will not show any reaction. HiO4 in this case, what we are getting? Break it, COOH, here also CH3, CH2, COOH. What you have to do? Just break it and add OH. Simple trick. If I take glucose structure, in detail we are going to see in biomolecules also. So every bond, like bond, all these bonds you can break based on above given requirements. Total 5 moles of HiO4 required. Once question asked how many moles required to oxidize glucose, remember 5 moles. So here 5 carboxylic acids you will get, but one that is HCO aldehyde. See, all these secondary alcohols, all these alcohols convert into carboxylic acid, but this CH2OH, this CH2OH alcohol convert into aldehyde. Last one. Okay. Similarly from ketone, if I see all these bonds you can break, adjacent bonds, and see the above requirements, which groups we can oxidize. Here also 5 moles, 2 moles of HCHO, 1 mole of CO2, 3 moles of HCOOH. 2 moles of HCHO from where? These 2 moles, HCHO. CO2 from here, remaining 3, these 3 will give HCOOH. And remember, here these cannot be oxidized. You can specify clearly, these cannot be oxidized. These groups you have to remember cannot be oxidized by KMnO4. Okay, next you see here, hot concentrated KMnO4 with KOH or H2SO4, strong oxidizing agent it is. So primary alcohol, what it gives? Carboxylic acid. Secondary alcohol, ketone. Like alkenes here you can see, alkenes here you will get carboxylic acid. Like even one more alkene, substituted alkene, here what you will get? Ketone. If there is R group here, then you will get ketone. If there is hydrogen, you will get carboxylic acid. Okay. And there is C. One bond as well as outside. So on oxidation by using hot KMnO4 or KOH, H2SO4 presence. So here what you have to do? Break the bond. The carbon with hydrogen, here you see, the carbon with hydrogen is converted into COOH. Carbon with hydrogen is converted into COOH. Without hydrogen is converted into ketone. See, here there is hydrogen. That's why it is converted into COOH. Here no hydrogen, converted into ketone. Mild oxidizing list. Here if you remember this, no confusion for exams. PCC, pyridinium chlorochromate, structure here like this. PDC, pyridinium dichromate, mild oxidizing agents, all these are. Collin's reagent, CrO3 2 pyridine. Jones reagent CrO3 plus acetone, mild oxidizing agent. CrO3 plus H2SO4 if they give strong oxidizing agent. One more Cu 300 degrees Celsius. Primary alcohol, any mild oxidizing agent, aldehyde. Secondary alcohol, ketone. Tertiary alcohol, you get no reaction here. But tertiary alcohol along with Cu 300 degrees Celsius, elimination reaction occurs, alkene is formed. MnO2 only for allylic and benzylic alcohols. We use this. It oxidizes allylic alcohol to aldehyde or ketone. For example, see, allylic position is this particular group. Next to double bond, carbon. After double bond, not immediate carbon connected to double bond. Next to double bonded carbon is allylic carbon. It is allylic carbon. So here aldehyde convert into alcohol is converted into aldehyde. Similarly, MnO2 see here. It is primary alcohol. It is secondary alcohol. Secondary alcohol convert into ketone. MnO2. So here allylic alcohol convert into ketone. CH2OH, MnO2 convert into CHO, benzyl alcohol. See here, MnO2 can convert only allylic alcohols into aldehyde. But CrO3, simply even CrO3 given, we can convert OH into ketone, even this one into aldehyde, this particular group into aldehyde. See the difference. Strong oxidizing agents, KMnO4 plus H plus, hot KMnO4, K2Cr2O7H plus, H2CrO4, CrO3 concentrated H2SO4, Jones reagent. Any of these strong oxidizing agents, primary alcohols acid, secondary alcohols ketones, tertiary alcohols no reaction. SiO2, selenium dioxide oxidizes CH2C double bond O into CO diketones. Means here already there is ketone, CH2 convert into CO. If it is given like this compound, so here as it is, so remaining other part convert into CHO. CH3 convert into CHO. So remember, here this particular compound, here there is already CHO, so one more carbon convert into CHO, aldehyde group. It is selective oxidation. Here, any one carbon you can select and convert into CHO. If it is symmetrical, any one you can select, one carbon you can convert into CHO. But if it is unsymmetrical, see here less crowded side, here more crowded side, between there is CO. Then, major product is less crowded side, where which is less crowded. If we, with respect to this, less crowded, less number of carbon, here more carbons. So it is less crowded side is major product. Less crowded carbon you convert into aldehyde. Minor product, more crowded this side. One carbon you convert into ketone because both these sides carbon atoms. See, middle you will get ketone. If it is adjacent last carbon, terminal carbon you will get aldehyde. SiO2. So what you have to do? Adjacent carbon, any one adjacent carbon you convert into ketone form. Okay. Side chain oxidation. When there is alpha hydrogen to benzene ring or pi bond. When there is alpha hydrogen with respect to benzene ring or pi bond at alpha carbon to benzene ring. Alpha hydrogen to benzene ring or pi bond at alpha carbon with respect to benzene ring. Like this one, alpha carbon with respect to benzene ring. Any chance of formation of pi bond at alpha carbon position from benzoic acid. See here, one more. Any chance of formation of pi bond at alpha carbon position from benzoic acid. See here. Here there is any chance of formation of pi bond at alpha carbon position from benzoic acid. In these two cases, you will get here side chain oxidation. Condition number one, alpha hydrogen should be a chance of formation of double bond at alpha carbon. See here. Strong oxidizing agents we have to use here. In this case, strong oxidizing agent. Here there is alpha carbon with alpha hydrogen here with respect to benzene. So this particular carbon connected to benzene directly converted to carboxylic acid. Here also there is alpha hydrogen, one alpha hydrogen. This particular carbon converted to COOH. Here no alpha hydrogen, so no reaction. Here there is alpha hydrogen, so COOH. Whatever directly connected carbon having alpha hydrogen convert into benzoic acid, COOH. Here also hydrogen, COOH. Here see carbon having OH here. Carbon having OH. So what happens here? Benzoic acid if it is formed, C double bond O you will get COOH. Here benzoic acid. Here see condition. If any chance of double bond, yes here CO, we know alcohol convert into carboxylic acid in terms of strong acid, secondary alcohol, or you can say double bond formation possible at alpha carbon. Next one, here what you will get? CH3, COOH, here also same you will get, they are tertiary, secondary. Here what we do? We break this bond because a CH alpha hydrogen is available here. After breaking, both are converted to COOH, COOH. But two adjacent COOH on heating gives H2O molecule found anhydride. Here also same, break the bonds here, break the bond, convert into COOH. Again, removal of water. So after the removal of water molecule, here you will get anhydride in both the cases. Okay, anhydride we are getting. Now, in this case, here it is NO2 is electron withdrawing group. NO2 is electron withdrawing group. NH2 is electron releasing group. So where there is more electron density, electron releasing group having more electron density. So we know oxidizing agent undergoes reduction, right? So it takes electrons from this given site. Oxidizing agent helps in oxidation. Helps in oxidation meaning undergoes reduction. Reduction meaning it takes electrons from the required site. That's why in first compound, ninth compound, this particular strong oxidizing agent attack at the site that is away from NO2. Attack at the site away from NO2 so that more electron density it can find. But in 10th compound, NH2 having more electron density. That's why here it is attacking at site near to NH2. So second ring it is attacking, in first case first ring it is attacking because NO2 is electron withdrawing group. Oxidizing agent attack at more electron sites. Specify oxidizing agent attacks at more electron density sites. Okay, so the oxidizing agent takes electrons at more electron density ring. Fine. JEE Main 2019 question here, C1s. Major product of the following reaction is alkaline KMnO4 H3O plus. Just now we discussed about side chain oxidation. What happens here? This alpha carbon oxidation occurs, convert into COOH. Simple question. JEE Main 2026, this year question. We know it is oxidation reduction, it is reducing agent. Even in detail we are going to see in upcoming chapter, but you studied in 11th also. Hydrogen platinum reduction occurs. KMnO4, hot KMnO4, what happens? If any double bonded, if any CH or carbon having alpha carbon with hydrogen, convert into COOH. What we do here? What should be the A here? First of all, if you break here, these two convert into COOH. Reduction, see what we are getting in reduction, see here. All two double bonds are reduced. Yes, two double bonds are reduced. When KMnO4 used, here bond breaks. Here COOH form. Remaining these two will form this one, COOH, COOH. So here probable answer it should be option 2. Because after reduction, these two double bonds, first of all, these two double bonds removed. Hydrogen added. Another possibility, outside this ring, we know the CH, wherever there is CH, so here bond breaks, COOH, COOH, and then this part is COOH, COOH. So outside, just now we discussed C, same question like this. Similar questions here, see, pattern already we discussed above. Okay, so here answer should be 2 here in this case. So more specific in your action, once if you properly go through all these reagents, easily you can solve JEE questions without any confusion. I hope all the questions clear to everyone. For more updates, follow the channel. Thank you everyone.